when I have these graphs, I kind of go back and forth on whether I read the passage and focus on that or focus first on the graph. And it really just depends on the module that you're in. So hopefully at this point you would know you're in the easy module. You haven't had terrifically difficult vocabulary words. Like, it's going to be clear. So this is the easy module, which means we can probably just focus on the chart and use that at least to kind of go through the answers in a preliminary way. So they look dense, but we want to kind of make sure first and foremost that they're factually correct according to the chart. And we can do that just by looking at the little pieces of data that are buried in these answer choices, right? So we are looking to support this assertion. So let's just make sure that we're supporting with real facts. So let me just show you what I mean by choice A. None of the planets have an orbital period, a period of more than 10 days. Okay, well, here's the orbital period right here, the third column. And look, this one does have an orbital period, that's hard to say, of more than 10 days. Like, there it is. Like, that's just done. Like, that choice is just wrong. It's factually incorrect. You have a number that is greater than 10, and the choice is saying that we don't have numbers greater than 10. So notice how easy that is, right? It's not about anything about the planets. It's just about looking at the right column and noticing a number is bigger than they said. Let's keep going. B, TOI 1478b has an orbital period of 153 days. Well, here we go. 1478b is right here. And the orbital period, we just highlighted that, and we just saw it's 10 point something. So the orbital period is not 153 days. 153 days is the distance from the sun. So that's just wrong. Like, again, it's just factually incorrect. Let's look at C. All the planets have a radius between 1.060 and 1.771 Jupiters. Okay, so here's the radius. So 1.060, is there anything less than that? No. Okay, so that's good. And 1.771? Yeah, that seems to be the highest. So that part's true. Okay, cool. And only two TOI 1333b, so that's this one, has an orbital period of more than 10 days. Well, orbital period is here. And it says 4.720. So no, it doesn't. So it's got to be D. Let's just prove it, right? Let's look at it and make sure. But every other choice is just factually incorrect. All you have to do is go to the right row and column, and it's provably wrong. D, each of the planets has a mass greater than 0.25 Jupiters. So mass in Jupiters is the first column. And yes, all of those numbers are greater than 0.25. So check. And all except for 1478b, so 1478b is again this one here, have an orbital period of less than 10 days. Yes, there's that 10.180 again, right? Like, all of them are less than that, except this one. So that's just true. So I have no idea why that supports Rodriguez. I don't know what they were saying, but it's the only one that is just factually true. So I think if you're in the easy module, this is a very reliable strategy. It's just looking at the graph and comparing it to the choices, literally just looking at the numbers and saying, is this true or not? That might not eliminate everything, and that probably would work in a couple of the hard module questions as well, or the first module, but it's more reliable, I think, on the easier section. So take from that what you will. But let's look at this. I'll just kind of give you the reason why I don't, from the passage, why that's useful. Hot Jupiters are gas planets that have a mass of at least 0.25 Jupiters, meaning that their mass is at least 25% of that of Jupiter, and an orbital period of less than 10 days, meaning that they complete one orbit around their stars in less than 10 days, while warm Jupiters are gas planets that meet the same mass criterion, but have orbital periods of more than 10 days, so this seems to be important. In 2021, Michigan State University astronomer Joseph Rodriguez and colleagues announced the discovery of 5 new gas exoplanets and asserted that 4 are hot Jupiters and 1 is a warm Jupiter. So this 10.180 is the one that's the outlier, clearly. So we need to support that. Each of the planets has a mass greater than 0.25 Jupiters, so that checks off with the first piece of information that they said. And all except for that one have an orbital period of less than 10 days. So that's the 4. That would be the hot Jupiter. So 4 hot Jupiters, 1, 2, 3, 4. So those are the hot Jupiters. And then the 1 warm Jupiter is the weirdo 10.180 that we keep talking about. So yeah, it fits. But notice it's just, again, kind of like, are numbers bigger or smaller than what they say they should be, right? So we could read the paragraph to know for sure which numbers matter, but it's also fine to just kind of go with the graph first. So It's going to depend on the question. This isn't always going to work, but I just want you to know that this is a perfectly valid way to get these questions right, is just focus on the numbers and see what that gets you.